want to solve, what we're going to have to do is actually take two equations at a time and eliminate one of the variables. You could try substitution with these as well, but elimination is actually going to be a lot faster than substitution would be. So, for instance, if I took the first and second equation, and I want to eliminate z, what would I have to do? Take the top one times 2. So we get 2x plus 2y minus 2z equals negative 2. 4x minus 3y plus 2z equals 16. When I add these together, we get 6x minus y equals 14. Okay. Unlike when we only had two variables, I don't have my answer yet, but I now have an equation with only two variables. What we're going to do next is go back to the originals. I have not used the third equation yet, so I have to use that one. And one of the other two that I already used, but I need to eliminate the same variable. So I eliminated z the first time, I have to eliminate the z again. Which equation do you want to pair this with to eliminate z? The first. If I want to eliminate the z, what would I have to multiply the first one times? We need it to turn into a positive 3, so multiply by negative 3. So I had to use the equation that we hadn't used yet, along with one of the others, to eliminate the same variable. Now when I add these together, negative 3x and 2x is negative x. Negative 3y and negative 2y is negative 5y. Positive and negative 3z cancel. Equals 8. Okay, it doesn't really feel like we've done much yet, but we are actually in pretty good shape. Because now when I look, both of these equations have x and y in them. So what we need to do is put these two together and eliminate something. So what do you want to do? Pick a variable. Get rid of x or y? X. So we would just take this one times 6. So my first equation didn't change. My second one would be negative 6x minus 30y equals 48. When I add those together, the positive and negative 6x cancel. 31y equals 62. So divide by negative 31, and y is negative 2. Once we have our y, we can start working backwards to get our other variables. So what I'm going to do is take my y and plug it into one of these two equations to solve for x. So if I just put it into this one, I know negative x minus 5 times negative 2 equals 8. And now I have x and y, so so we can plug those back into one of the originals. Doesn't matter which one, if I just went with the first one, x is 2, y is -2. And get that z is 1. Writing these, we just do alphabetical order, x, y, z. So 2, -2, 1. So adding that third equation and variable really increased the work to get to these problems. The idea is the same, just substitution elimination, but it's going to take longer. And if we added in a fourth variable, it would be even more. We're not going to do any more than 3. But are there questions about how I got there? Let's do this problem. So our strategy, take 2 equations and eliminate a variable. Then we'll have to use the third equation and eliminate the same variable. So what do you want to cancel out? Y's? Okay, I heard y first, but you can do any of them. There's no right or wrong. So if I just start with the first 2. If I want to eliminate y, what would I take the first one times? So we get 3x minus 3y plus 15z equals -18. Second equation we didn't change. We know sometimes you might have to multiply both equations by something. So when we add 3x and 3x would be 6x. Positive and -3y cancel. 15 minus 1 is 14z.
So you can't go ahead and do the bottom, like multiply the bottom by -1, take out all your y's and
No, because you need 2 different equations at the end, so we can put them together. So eliminating, using all 3 at once wouldn't help you. So now we have to use the third equation because we haven't yet. I have to put it with one of the first 2 to eliminate the y again. So which one do you want to put it with? Second one. If I do the second one, what do I need to multiply the second one by? Plus 1 is -2. Positive and -3y cancel. 1z plus 2z is 3z. Equals -5. So now I have 2 equations with x and z. We have to put those together to eliminate something. So what do you want to do? Okay, so we could take this one times 3. I'm going to put them together. Positive and -6x cancel. 2z equals negative 23. Divide, and z is negative 1. And then we just start working backwards. So I have to plug that in somewhere. So if I just put it into this equation. Negative 2x plus 3 times negative 1 equals negative 5. And then when I put it back in, either of those, or any of the three equations, if I just go with the first one, x is 1 minus y is 5 times negative 1. And get y to be 2. X, y, z. And again, you can check them, you just have to put them back into all the originals and make sure it works. What questions do we have on this? I'm gonna go out of order. I'm gonna go to this one next. What variable do you think would be easiest to get rid of this time? Z. The third equation doesn't even have a z, so it's going to be a little bit easier than the other two problems. So what you need to do to start is take the first and second and eliminate z. Do we have to do anything special in order to eliminate? No, we're just going to add them together. So 3x plus 2y equals 3. So now I have to take the third equation, we haven't used it yet, and the answer we just got out. If I wanted to eliminate x, what would I multiply this one by? Or sorry, negative 1. So that gives me negative 3x minus 2y equals 0, and the equation we just got, 3x plus 2y equals 3. Well, when we add, negative 3x and positive 3x cancel. Negative 2y and positive 2y cancel. So we get 0 equals 3. What does that mean? No solution. Now what's the word we use when that happens? I told you, every time you have a no solution, you have to write this. Remember at the beginning we said any system that has a solution is consistent. If it doesn't, that is inconsistent. we're going to have so many people gone tomorrow, I'm going to try to get through most of my examples today, and then maybe just have tomorrow more as a work day. So, let's just see if we can get through the last few. So you have to take any two equations and eliminate any variable. I'm seeing a lot of people start at different places, so I won't be able to do it the same way as everybody, but what do you want me to do? X's, okay. So if I just took the first two, if I want to eliminate x, I take this one by 2. So we get 2x plus y plus z equals 9, negative 2x plus 2y plus 2z equals 2. So those cancel. 1y and 2y is 3y. 1z and 2z is 3z equals 11. Alright, some people, if you chose to eliminate y or z there, you got them both to cancel, so you actually got what x equals at this point. If not, we'll keep going. We have not used the third equation yet, so I have to use that one, and I have to eliminate my x again. So I'll take the second and third. If I want to eliminate x, this time I'm going to multiply the second one by 3. So when I add those, my x's cancel. I get 2y plus 4z equals 12. At this point, I have to put these equations together and eliminate something. If I want to eliminate y, what would I have to take this one times? -2. And this one by 3. So if we add those, the y's cancel. We get 6z equals 14. Divide, and we're left with a fraction, 7/3. Now I have to start plugging it back in. So I'm going to put it into this one. So we have 3y plus 3 times 7/3 equals 11. So 3y equals 4, and my y is 4/3. Then we can put it into any of them. So if I just did the second one, I have negative x plus y, which is 4/3, plus z, which is 7/3, equals 1. I subtract that over and divide to get x to be 8/3. So my answer, x, y, z, 8/3, 4/3, 7/3. So fractions can happen on these.
Can you look at mine?
Absolutely. When I look at this one, I have 3 variables but only 2 equations. So that means I'm not going to be able to get the actual answer. This is one of those cases where sometimes we solved it and we got 0 equals 0. And we knew that wasn't a no solution, that was when we just wrote, they were 2 equations for the same line. And we wrote them in terms of one of the variables. So if you have more variables than you do equations, we can't get the answer. We're just going to write it in terms of whatever variable I ask for. So when I say write it in terms of x, that means x stays x. I need formulas for y and z that involve x. So I would start with this one. If I wanted to get y by itself, you would just subtract over your 2x. So y is 4 minus 2x. So So that's my y. Now we need z. So to do that, we're going to use the first equation. So the first equation is x minus 2 times y. But instead of my y, I'm going to sub in what y is equal to, which is 4 minus 2x. Trying to find a formula for z, so we are solving for z. So if we distribute the negative 2, we get 5x minus 8 plus 3z equals 7. If I'm going to get z by itself, I have to subtract over my 5x and add my 8. So z is 15 minus 5x divided by 3. So because I had more variables in equations, we couldn't get a number answer, we just found a formula. So if I know what x is, I can figure out what y and z have to be. Alright, I'm stopping there. There's a Math Excel assignment open. Like I said, it's the same assignment for today and tomorrow. So tomorrow I'll do at least one problem at the beginning, and then the rest of the time will be work time for that.